Hey students, this is Miss Went, and I wanted to assist you with getting started with this worksheet called Series Circuits. Okay, so there's some reading up here. Hopefully you've done that. Reminder, we have a formula here to find current of a circuit. We are going to take the voltage divided by the resistance. Okay. So let's take a look at our first problem here. So in this circuit, we have a 6-volt battery here, and it looks like we have 2 light bulbs, and each light bulb has a resistance of 1 ohm. All right, so question A, the total voltage across the bulbs, well, that's going to be from the battery, so our total voltage is 6 volts. We don't have to do any math, for just look at the picture. The resistance of the circuit, so the total resistance is going to be just adding the different pieces together. So in this case, each light bulb is worth a resistance of 1. So our total resistance is going to be 2. And this little kind of circle symbol is an ohms. So you can draw that symbol, or you can just type out the word ohms. Same thing. I think it's easier to type the word ohms instead of finding the symbol on my keyboard, but if you're handwriting, the symbol might be easier. All right. Now, the current in the circuit, we're going to have to use that formula. Okay. So our formula is the current stands letter I, and we need to take the voltage divided by the resistance. Okay. So for this problem, we had a voltage of 6 and our resistance was 2. So our current for this circuit is going to be 3, and this the unit for current is in amps. So 3 amps is going to be our answer there. Right? Letter D. What is the voltage drop across each light bulb? Okay, so what that means is we start with 6 volts here, and as we get to the end of the circuit, right, we have to get down to 0 because the beginning and the end has to be a difference of 6. So if we think of the beginning as having 6, we have to think of the end as having 0. So each one of these bulbs is using part of that. Okay? So I know that if each bulb has a resistance of 1, and I figure out that the current is 3, then my current is 3, the resistance is 1. 3 divided by 1 means that our answer is going to be 3 volts. All right, for letter E, draw the path of the current on the diagram. This is going to be tough with the program I'm using right now, but what you would do is take a pen or a writing tool and draw an arrow from the positive to the negative. And you don't have to go like all the way around the bulbs. You can just draw the arrow on one little part, like right in here. So if you start your arrow right where I've got my cursor and just kind of bring it down over here and say starts here, goes this way, that would be the path of the current. So just drawing an arrow showing where the electrons are flowing. All right, so here is a good model for how to do this first problem. The second problem is just like this, except it's going to add one more light bulb. Okay, so I'm going to leave that one for you to work through. Okay, so instead of a resistance of 2, we're going to have a resistance of 3. So you'll have the same idea for each problem, but now your resistance is 3, so that's going to change your numbers. Okay. Now, number 3, what happens to the current as more light bulbs are added? Well, compare. Our current with 2 light bulbs was 3 amps. Figure out what your current here was, and then answer the question. Does the current get bigger, smaller, or stay the same? Okay, and then what do you think is going to happen to the brightness of the bulbs? So more current would give you a brighter light bulb. Less current would give you a dimmer light bulb. So what do you think is going to happen to the brightness? So after you do this problem, you're going to have to compare your first problem to your second problem and then answer these two questions. Okay? Now, third page. This one looks a little different, but we still have resistance here. It's just instead of a light bulb, it's a different kind of resistor. Okay, so these two problems, again, very similar. This time we have 6 volts, and we have 2 resistors here, but the total is 3. And that was the same total as this guy here, total of 3. So you may notice some similar answers coming from that. But the only difference is the voltage drop. You're going to have to do each of these separate because they have different numbers. Okay, so once you figure out the current, you'll have to use a resistance of 1 for the first, and then calculate a resistance of 2 for the second. So you're going to have to do 2 math functions to answer C correctly. Okay. Letter 6, very similar, except we have 2 batteries now, so our voltage is larger. Otherwise, it'll be doing the same type of problems. We just have a voltage of 12 now. And then down here for number 7, again, very similar here, except now it's giving you the voltage and the total current. So you're going to have to try to work backwards from that to find the resistance. So if current equals voltage divided by resistance, I know my current is 0.5 amps. I know my voltage, right here, 1.5 plus 1.5 would be 3. And I do not know the resistor, but there are 3 of them. Okay, so whatever that is, I better write it like that. There you go. So there are 3 resistors. I don't know what each resistor is, but I know that 3 divided by whatever that's going to be has to be 0.5 amps. Okay, so that's kind of how you'll figure that out, and then you'll figure out the voltage drop, draw the circuit just like you've done in your other problems. Okay, and then this one's really similar too, except each one of these is different, so you'll have to calculate the voltage drop separate for each resistor. Okay, so hopefully I've given you kind of a start here to get going. Now you may run into questions as you go, and that's totally cool. Remember, you can message me, we can Zoom together, whatever you need to do. But hopefully this start will kind of get you going. And again, if you have any questions, you can always message me. Thanks, guys. Have a great day.